All right, so lesson 4, to finishing up inscribed angles. Again, this is going to be kind of the last part before the quiz, but everything here has to do with stuff that's happening inside the angles themselves, or inside the circles themselves. Okay? Has anybody heard the word inscribed before? Jesse, you've heard it?
Yeah.
You know what it means? You just not. Yeah, it's like written inside there. So like if you have a book that's been inscribed, like somebody will write a little note inside your book and give it to you. Sometimes when people get married or engaged, they'll like inscribe or write something inside of a ring, like maybe their anniversary or something. If you get a fancy, like back in the good old days, like of Back to the Future 3, and you got that fancy pocket watch, that one was inscribed with a little message from Doc. That's heavy. Anyway, so this stuff when we're talking about the inscribed angles. Inscribed angles are going to be the things that are written inside of the circle itself. We'll also be able to use kind of this information to solve some information on some polygons. So polygons meaning just those shapes. So the 2 definitions that I'll let you write down, that I'll talk about them, are going to be inscribed angles and then an intercepted arc. All right, an inscribed angle. Inscribed angle is going to have a vertex that's on the circle. Okay, so coming down, it has 2 chords and it's going to go to the opposite side of that circle. Okay, you're going to have 2 of those points that will come together. That's going to be what's called the inscribed angle. Notice they are both chords. They're not ending on that central point. They're going all the way across to the other side of the circle. Okay, and then the next definition is going to be that intercepted arc. An intercepted arc, you're going to have that inscribed angle. The inscribed arc is going to be that arc that goes between the 2 parts of the chords that are across the top. Okay, so that's what that inscribed angle is. It's what the intercepted arc is. You won't hear the intercepted arc a lot, but sometimes they'll give you the definition and say the intercepted arc for this segment is this. So just know that's what they mean by it. Okay. On to kind of the definition stuff. Don't worry about that. We're just going to start off with the inscribed angle theorem. You can put down the example if you want, otherwise I'm going to explain it in just a second. All right, so I've got the picture. It's going to be on the board. I'm going to leave it on there for the rest of class today, but I'm also going to draw it on here. If I have a circle that looks like this, pretend it's more round, okay? And I've got this angle that comes down here. Here's that central point, okay? And I say that this angle down here is going to be 50 degrees. what this inscribed angle theorem is saying is that, again, I still have the same section here, the same A and B. But if my inscribed angle all the way down here is 50 degrees, hopefully you can see a little bit better that this one looks bigger, right? This one, because again, this is going all the way across the circle, so like twice as far. The rule is that this central angle, instead of the inscribed angle, is going to be twice as big. Okay, and that's what this says. It's saying that if they give you, if you're trying to find angle 1, you can use this angle, or that angle right here, divided by 2 to figure out the opposite side. If they give you the opposite side of this angle, okay, you can multiply that by 2 to figure out the central angle. Okay? That's what the inscribed angle theorem is really saying. Again, same rules, either set them equal to each other or multiply by 2, divide by 2. That's the majority of the last 3 lessons. Okay? Except for the end of this lesson, I'm going to throw a wrench into the one rule we have. All right, so looking at this very first definition, this first sample problem. I'm going to get out my highlighters here. It's saying we're going to use this circle to find the measure of arc CF. I'm just going to start off with CF. Okay? CF is going to be this arc right here. Okay? It looks like it's a diameter, but like the center of this circle is like up here somewhere. Okay? So if I look at this arc, CF, and I can see that this angle way up here, they do give me an angle for. Okay, I've got this arc right here. I got this inscribed angle way up here that says that this angle is 40 degrees. If my goal is to find what the measure of arc CF is actually doing, I'm trying to figure out what the measure from like there to there would be. So for me to figure that out, I'm going to say the measure of CF is going to equal that 40 degrees, because that's on the opposite side, right? And I want to find the central one. So if they give me the smaller number, the outside, I'm going to take that, I'm going to multiply it by 2. Because they gave me this angle that's way at the other side, that inscribed angle. Okay? And I want to find this one. So I'm going to take that inscribed angle times 2. So I'll be able to find out that the measure of CF is going to equal 80. That's it.
Are there any ones where they don't give you that angle? Give it to you in place?
Kind of, not really. So here, I'm going to do the next one because it's going to be a little bit different than it. Not like a ton different, but it'll be a little bit different. This next one says it wants me to find angle C. Angle C is this one right here. But yeah, for these angles, no, nothing nearly that. Okay, so it tells me that this angle is going to be an inscribed angle. I'm trying to find out. But, guys, the central angle, one that's going to go from like here to here, is 98 degrees. So if I want to find the inscribed angle, the one that's opposite of this one, what I'll do, let me get my handy-dandy highlighter. I'm going to have angle C is going to equal, I got 98, but because that's just for kind of this portion here is 98 degrees, I need to divide that one by 2. Because again, if they give you the angle on the outside of the circle, that's just telling you for that central angle, that central arc. If they write it inside the circle, that's usually going to be that opposite. Yeah, it's going to get smaller. So I got 98 divided by 2, which tells me that angle C is going to equal 49. So far, so good? Okay. So this one, if it gave me the number on the outside, like out here, what it's trying to figure out, or what it's trying to tell me is that 98 degrees is from D to that central point to E. So it's just giving me this one. So if you see the number on the outside, usually that's just going to be for that, from the central point to there, and it's trying to find the inscribed angle. If they give you the number inside the circle, usually way off on the side, that'll be an inscribed angle, and you're trying to figure out the outside arc. Okay? So this is one where hopefully you guys will talk me through this. Okay, they give me this one here. Is this going to be an inscribed angle or a central angle? Inscribed angle, because it's inside the circle. Okay, that's kind of another way to figure it out. So if angle Z is going to be 52 degrees, it's going to want me to find the arc for X, Y. So if I want to find the measure of arc X, Y, thoughts on what I do? Any? Yeah, you said it. Multiply by 2. I'm going to take 52 times 2. So it's going to tell me the measure of XY is going to equal 104 degrees. Okay, if I want to find angle X, that's my other one that I want to do. Angle X, so angle X is going to be the one that's down here. It gives me that 86 degrees. Is that on the inside of the circle, or is that an inscribed angle? It's outside. So it's going to be that central angle. So how will I figure out what angle X is going to be? Perfect. 86 divided by 2. So angle X is going to be 43. Again, that part is, just that simple. They're not going to give you extra formulas and all that sort of stuff. Feeling good? Okay. I'm going to give you this one. I want you to do it real quick. I give you the circle, and it looks like this. I want you to find arc AB. Just show me that you have it. Yes, sir. Yes, sir. Yep. Yes, ma'am. Perfect. Yes, ma'am. All right, you guys got it. The length of AB is going to equal 64. All right, on to the next part. Next definition for you. Again, I'm going to let you know it's hard to see the colors. Oops, I took off a little bit of it. But it's saying this angle here, or this arc right here, these two inscribed angles are sharing the same arc. So what you did before is if they gave you this arc over here, you divide it by 2 to figure out what that one is. But if it's the same arc, that'd be divided by 2 as well, right? So these are going to be the exact same length if they share the exact same arc. That's what it's saying. It's saying that angle B, angle C, they both share the same arc AD, and because of that, angle B and angle C are going to be equal to each other. Yeah, these are both going to be the exact same inscribed angle degrees. That's why they got out. Yeah, so this part is just showing you. It's not going to show you that they have that one. This is the theorem to show that these will be the same. When you get the next 2 sample problems, it won't give you that part. But you should know that part of it. Good. Okay, so if I look at this one, okay, I'm going to get on my highlighter here. Oops. Nope, just go there. So here's my highlighter. I know that if I'm looking at this angle down here, this one here, it has this for an arc. And then if I'm looking at this angle over here, it has this for an arc. Are these the exact same arc? Yeah. So if these are the exact same arc, what can you tell me about these two angles? They're the same. If things are the same, how can we solve them? Set them equal to each other. So this one's saying find the measure of angle R. So I'm going to set these two angles equal to each other. So I got 12x minus 13 equals 9x plus 2. I'm going to go through and I'm going to solve for it because it's just regular algebra at this point. I got 12x equals 9x plus 15 minus 9x to both sides, which tells me 3x equals 15. Divide both sides by 3. My x value equals 15. Sorry, not 15, equals 5. Gotcha. My x value equals 5. But it's asking, what's the measure of angle R? Fantastic, plug it in. As I'm saying to plug this one in, if I look at both of these are the same angle, right? Yeah. So does it matter which one I plug it into? No. Again, if you have them equal to each other, you can choose whichever one has easier numbers for you to work out mentally. I'll do the bottom one because things times 9 are easy for me. So I'm going to take 9 times 5 plus 2 gives me 45 plus 2. So angle R is going to equal 47. I could do the other one. I could take 5 times 12, which is 60, minus 13, which is going to give me 47. Either way, it's going to give me the same answer. But again, if they're set to equal each other, I can choose either side. Feeling awesome? Of course. I love it. I want you to do this one then. Okay. It says angle S, I'm going to draw my little line here, equals 3x. Angle V, this one over here, is going to equal x plus 16. Do they share an arc? Yeah, they both share TU, right? So go ahead and solve for angle S. So I want you to do angle S equals. Done. Yes, ma'am. Yes, sir. Double check that. Okay. So this one set up great. We got a minus the x on both sides. I think you just added the x instead of something. Yep. So 2x equals 16. So 2x, suppose we'll put 2x right here. Equals, what number is this one? 16. So now we're going to take both of those and add by 2. Yep, so x equals 8. And now you can plug it back into 1. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, sir.
So when you're looking to see if they have like the same arc, it's like you go, so I guess you put an S and you just go up.
Yep, I just follow both of those together. So like here's the two chords that come down to S.
Oh, I see. Yeah.
So I look at that. These ones have the same chords that go together.
Okay.
Yep. All right, so you guys should have put it together. X equaled 8, and then S is going to equal 24. Yeah, X equaled 8. All right. Sounds fantastic. Here is going to be the next definition. Okay. It works the same as the other ones that you've seen before, but it's just kind of a quick little snapshot to give you the right answer. This is a diameter, meaning it goes to the central point. How many degrees is a semicircle? 180. That tells me that the thing on the opposite side of that is going to be 90 degrees. So instead of having, because again, 180 divided by 2, 90 degrees. So again, if you have one that's a diameter, just real quick math sort of thing, means that the angle on the opposite side is going to be 90 degrees. Okay, that's what this is saying. You get a semicircle, so that's 180, half of that is going to be 90 degrees. So if you have a triangle that gets made out of the diameter, you will have a 90-degree triangle. What sort of stuff do you guys know about 90-degree triangles? If you get two sides, can you figure out the length to the third? How? Pythagorean theorem, yeah. If you are given if you have this 90-degree angle up here, and you're given one angle, can you figure out what the measure of this one is? Yeah, because all the sides of a triangle are always going to add up to 180 degrees, right? There's a lot of stuff that you guys know about triangles based on the last couple chapters we've done, that this type of triangle, this type of circle with the angles, we're able to get a lot more information out of it because of the stuff that you already know. So that's what this theorem says, is that if you have a diameter and you've got two inscribed angles that are coming from that ends of that diameter, it'll be a 90-degree triangle. All right, so I'm going to look at this one here. This first one we'll do together. It's the diameter. If it's a diameter, angle C has to be what? 90 degrees. Sweet. All right, here's the only one that's not going to follow that rule where we make everything equal to each other. I'll let you write it down. Sorry about that. All right, so again, we already mentioned it. If it's a triangle, how many degrees are inside a triangle? 180. If one of the sides is already 90 degrees, what will the other two sides always add up to? 90 degrees. Fantastic. So I've got this triangle here. I've got this angle plus this angle, and you told me that both of those are going to equal 90 degrees. Or if I wanted to add every single one of them, they're going to equal 180. If I did this one plus this one plus this one, all three angles will equal 180 degrees. Okay, but because one's 90, I can kind of cut out the middleman, and I can just say x plus 4 plus 8x minus 4. All of that is going to equal 90 degrees. Okay, this is the only one where I'm going to set everything equal to each other. So I've got x plus 4 plus 8x minus 4. All those together, since they're on the same side, I can combine like terms. So I got 8x plus x, which tells me I got 9x. 4 minus 4 equals 0. So I've got 9x equals 90. Divide both sides by 9. I got x equaling 10. The last thing it asked me, find the measure of angle B. So I need to plug it back in to that specific angle. So I've got 8x minus 4. So instead of having x, I'm going to substitute in that number. So I got 8 times 10 minus 4, which gives me 80 minus 4. Angle B is going to equal 76 degrees. Thumbs up, thumbs down. How are you guys feeling? Super. I love it. Okay, this is one I want you to do all on your own. I don't know why that went goofy. Angle A is going to be 7x. Angle B is going to be 3x. I want you to find angle B. So, right here, minus and 10 to divide by 10. Okay, so set those last two angles up so that they're going to equal 90 degrees. They're on the same side, so you add them. Oh. Okay. Good. That's it. Yeah. I get to solve. I want to know what angle B equals. Angle B? Yeah. Yeah. All right. You guys should have gone through it. As you solve the whole entire thing, you should have figured out that x equaled 9, and then angle B should have equaled 27 because you took 3 times 9. Okay. This last part, don't worry about writing it down. I want to explain it to you, but I'm not going to have it on any tests or quizzes. I just want to kind of explain this stuff from the circle for you. Here, I'll zoom in. Again, don't worry about writing it down. I just want to explain it. Realistically, if you can figure out triangles, that's what I'm most worried about. Okay? Because yeah, you'll be able to kind of figure out all the other degrees as they go through. What this is saying, if you have a polygon, if you got 4 sides, the opposite angles, like angle K and angle M, together they'll be supplementary. Meaning that this angle and this angle together will equal 180 degrees. Okay? I'm going to draw this thing out just so you can visually see it. So if I have my chord going across this way, okay? So I've got this angle, whatever it is over here, and then divided by 2, because you have that whole entire length here, divided by 2, and then you got the rest of this arc, divided by 2. No matter what, this part and this part together will equal 360 degrees, right? So because if you're dividing them by 2, they will automatically be 180 degrees. It's just a fancy rule of the polygons. Okay? I'm not going to put it on a test if you can figure out the triangles, because again, as soon as I drew that line that went across, I broke it down into one triangle and then a second triangle. So if you can do triangles, that's what I'm most worried about. But this last part, just wanted to kind of show it to you, is that if you have a quadrilateral, their opposite angles will be supplementary from each other. Good? That's all I got, guys.